Welcome to The Explainer. So, today we're going to talk about a term you're probably hearing everywhere: AI agents. We're going to break down what they actually are, how they think, and why this is such a huge shift from tools we command to partners we can actually collaborate with.
And this quote from Google's own guide, well, it just gets right to the heart of it. We're not just making language models a little better at chatting. No, we're evolving them from things we talk to into autonomous partners that can actually do things for us out in the world. That's the big leap here.
For the longest time, we've kind of treated AI like a vending machine, right? We put in a command, it gives us an answer. We ask for a picture, it makes one. Every single task is its own little transaction. The AI does its job, and then it just sits there, waiting for us to tell it what to do next. So that's the old model, the passive predictor. But the game is changing. We're moving towards the autonomous actor. And this is a totally new kind of software. You don't just give it a single prompt, you give it a goal. And it figures out the chain of actions it needs to take to get there all by itself.
So how are we going to wrap our heads around this huge shift? Well, here's the plan. First, we're going to dissect an agent and see what it's made of. Then, we'll look at how it actually thinks. After that, we'll meet the whole family of agents, from the simple ones to the really complex ones. Look at the very real challenges of making them work, and finally, really understand why this is all about a new kind of partnership.
All right, let's pop the hood and see what makes these things tick. Fundamentally, an AI agent is built from three main parts, and the best way to think about them is with a simple human metaphor. It's got a brain, a set of hands, and a nervous system. First step, every agent has a brain. This is the large language model at its heart. It's the engine that does all the heavy lifting, the reasoning, the planning, the decision-making. It's the part that understands the goal and comes up with a strategy. But a brain by itself can't really do anything, can it? It needs hands to actually interact with the world. And these hands are its tools, things like APIs or databases. This is how the agent can go from just thinking about something to actually searching the web, sending an email, or pulling your report.
And finally, you've got to connect that brain to those hands. That's where the nervous system comes in. This is the orchestration layer. Think of it like the conductor of an orchestra, managing the whole process and deciding in real time, okay, is it time to think more, or is it time to use a tool and take action? So you've got the brain, the hands, and the nervous system. How do they actually work together to get stuff done? Well, it all comes down to this continuous loop, a process that's actually pretty simple in concept, but incredibly powerful when you see it in action. It all kicks off when the agent gets a mission. First, it scans the scene, figures out what it knows and what tools it has. Then its brain gets to work, creating a plan. It takes the first step with its hands, and then, and this is the most important part, it observes the result. This think, act, observe cycle just keeps going, getting smarter with each loop, until that mission is complete.
Now, this is where things get really interesting. Once you have this basic architecture down, you can start scaling it up. You can create this whole family tree of agents, with each generation getting more and more capable. So at the very bottom, level 0, you've just got the brain. It knows a ton about baseball history, for example, but it's kind of trapped in time. It has no idea who won last night's game. But give it some hands, like a search tool, and bam, you've got a level 1 agent that can connect to the world and get you that score. But the real magic happens when you jump to level 2. This is where agents go from just fetching information to actually becoming strategic problem solvers. They can handle a complex goal, like finding a good coffee shop halfway between 2 different offices, and just break it down into all the necessary steps to get it done. And at the very top of the ladder, well, you get whole teams of agents working together. You can have a project manager agent that takes on a huge goal, like launching a product, and then it delegates all the smaller tasks to other specialized agents, one for research, one for writing copy, one for coding. That's how you can automate an entire complex workflow. Okay, so this all sounds absolutely incredible, right? But, and this is a really big but, taking an agent from a cool demo to something that's actually reliable and safe enough to use in the real world, that is a whole different ballgame. It is not easy. See, agents aren't like the software we're used to. They're probabilistic, which means they make educated guesses instead of just following rigid rules. That makes them a little unpredictable. And that's why this whole new field called agent ops is popping up, to figure out how to do things like test them properly, debug their thought process when they mess up, and give them autonomy without opening up huge security risks. So why go through all this trouble?
Because getting this right isn't just about building slightly better automation. It's about creating something totally new, a fundamental change in how we relate to technology.
When you get it all working, when the agent has clear goals, good tools, and a way to remember what's happened, it stops feeling like a piece of software you command. It truly starts to feel like a collaborative partner, like a brand new, super capable member of your team, working right alongside you.
And that leaves us with this really big question to think about. As this technology keeps evolving, are we just building the next generation of software? Or are we actually building our next generation of colleagues?